Hello everyone, welcome to this panel where we're going to discuss today with the four guests how to use ZK to implement an L2 on Bitcoin. So today we have with us Yovela, co-founder at Fiamma. We have Orkun Kılıç, co-founder at Citrea. Ayush Gupta, co-founder at LayerEdge. And Duan, dev lead at ZKM. Thank you for being here with me today. And I'm very excited to talk about Bitcoin scaling with you. So for context, Bitcoin is the most popular blockchain of today, also one of the most adopted and trusted, but it lacks some scalability features for it to have a more widespread usage. And today we're going to discuss how ZK can be used to address these scalability issues through L2 implementations. And we're also going to explore the role of OPCAT and BitVM recent developments on how to make Bitcoin more programmable and efficient. So the first question I would like to ask is, how do each of your projects use ZK? And what are the unique value proposals of your designs? And perhaps we can start with Yovela.
Hello, everyone. Yeah, so I'm the co-founder of Fiamma. So I will introduce our project a bit. So basically, our vision is to build the future of finance and the internet on Bitcoin. So there are a lot of missing pieces, a lot of infrastructure that we need to build. So we think that definitely ZK is the end game for unlocking the potential of Bitcoin. So we build a ZK verification layer on Bitcoin that implement BitVM2 to inherit the network security of Bitcoin. And also, we are also building a pragmatically trusted Bitcoin bridge, also based on BitVM. In the future, we will also launch more infrastructure necessary to achieve our vision.
Yeah, hey everyone, I'm founder of Citrea. Citrea is Bitcoin's first ZK rollup. It uses Bitcoin as a data availability and settlement layer, basically, to scale its security with better user experience and developer experience. It's a type 2 ZK VM running on Bitcoin where developers can just pick their existing programs and deploy. And it will run with full Bitcoin security with a trust minimized bridge built in, so they can use Bitcoin in action without actually going through centralized and custodial solutions like wrapped Bitcoins or any other sidechain, basically.
Hi everyone, I'm Ayush. I'm from LayerEdge. So we aim to become the go-to security and verification layer on Bitcoin, and we do it like using the aggregation. So that we are trying to bring the cost of verification of a single chain on Bitcoin by at 2 to 4% of the current cost using aggregation.
Hello, this is different from the ZKM and God Network. So basically, God Network is a Bitcoin layer 2 built on the ZKM and achieved the Bitcoin level security by verifying the proof on Bitcoin. Okay, so that's the first very important things that we use the ZKP to scale the BitVM, the Bitcoin. Okay, and another very important feature of the God network is we implement the decentralized sequencer. That means the decentralized sequencer can attract different participants, like the miners or the community, the communities. So we can use the ZKM to now we use a proof network from the ZKM to generate the proof for the blocks, and then we now the us to inherit the security from the Bitcoin. Okay.
Thank you, everyone. So one of the first things that comes to mind, to my mind, as someone that is not very knowledgeable about BTC scaling but has quite some knowledge about Ethereum scaling, is what was the primary reason why we could not build a Bitcoin scaling up till now, and what recent improvements in ZK technology have made Bitcoin scaling possible now?
Yeah, that's a very great question. So we know that ZK is a very prevalently used technology in Ethereum scaling. So basically, essentially, we all know that it can, just compress very complicated computations into very, small size, simple ZK proof, so that it can be verified really effectively on Ethereum. However, we cannot actually do that in Bitcoin until now, because you need to, if you want to, move that technology, the ZK in Bitcoin, the first thing is that you need to enable Bitcoin to verify the ZK proof. But now we have many new paradigm that can open the door for us, like BitVM. So we can enable Bitcoin to optimistically verify ZK proof. So which means that we can now ensure the state that they're being correctly verified by Bitcoin, and also for the asset bridging between Bitcoin L1 and also Bitcoin L2, it could become pragmatically trustless. So with this technology, we can say that what we are building are real Bitcoin L2s.
I think Bitcoin has been the home for the first of all applications. Even before Ethereum, people launched Satoshi Dice, people launched colored coins, Mastercoin, and even Vitalik wanted to launch Ethereum on Bitcoin through Mastercoin in 2014. But he couldn't because the tooling was not enough. And Bitcoin has changed a lot since then. Not maybe a lot compared to the other blockchains, but some important soft forks happened, like Segwit and Taproot, which eventually allowed us to use the whole block as a data availability layer instead of just stacking with 40 bytes or 80 bytes. So with this way now we are able to use Bitcoin as a data availability layer, which is the edge of being a rollup, where you get the full security of Bitcoin block space, because now we have the double spend guarantee, you have the censorship resistance of Bitcoin just transmitted to our rollup Citrea. And the second thing was obviously BitVM. I think last year, October, it was Robin's paper that came out. And immediately after, my chief scientist and I flight to Bitcoin Amsterdam to talk with him actually. And in a month or two, we realized we can actually build a bridge using BitVM. And since then, we have been working on it. It's been more than a year. Recently, the BitVM Alliance founded. I think you are the only one in here that's in the alliance with us as well. So we are targeting to finish the BitVM implementation until end of the year. And hopefully after, we will have a fully trust minimized bridge that's only possible to build into a rollup, not another sidechain or other construction, basically.
Yeah, I totally agree with you on the fact that after the BitVM, the whole space has gone a lot of boost, because once we are able to do certain verifications natively on the Bitcoin side, then that opens a big can of application that can be built. If we go towards the coprocessor way, then using that we can actually build a lot of dApps which were earlier not possible, where all the computation will be offloaded to a coprocessor, but all the verifications can be done natively on the Bitcoin side. And as we see the growth of ZK applications heavily into the Bitcoin ecosystem, we designed we found that the verification was relatively little bit costlier for the smaller application, which were basically built for one specific use cases. And for that purpose, we started working on the verification layer and how we can make it accessible to everyone.
Since basically we have a lot of limitation when we implement the verifier on Bitcoin. That's we have some solution like the mission in BitVM. But here I want to say that yes, when we implement the verifier, most of the computation happen in the middle loop. So you can see that I think there's a paper that named on proving pairing. There are a lot of optimization skills there. So the problem is, can we implement all those optimizations on BitVM2 right now? I think the answer is no. There's still a long way to go, I think. So, yeah, so back to our projects, ZKM and Core Network on ZKM. So ZKM natively produce a proof based on the GNAC for the final proof. You know, ZKM is a layered architecture. We use a stack plank in the for the VM, and then we have a stack to SNAC, and the final proof is produced by GNAC. I don't know the difference between GNAC and ArcWorks. You know, BitVM to implement the verifier for the GNACs. Okay. So the middle loop for both is different. The middle loop of them is different. Oh, okay. So I want to say is how to optimize the verifier. Maybe is the key to implement the verifier on Bitcoin. Yeah, I just want to mention this part.
Okay, thank you. And so, from what I understood, BitVM was kind of a breakthrough in how to approach BTC scaling. But the other question I have is, how vital is it? And also, if OPCAT were to be enabled again on Bitcoin, what are the performances trade-off between using a BitVM approach, using OPCAT? Can you tell us more about it?
Yeah, sure. So for now, a lot of people will question, like, you know, if BitVM is ever feasible, or how long does it take us to reach production readiness? But the answer is that actually it will be production ready very soon. Like, so for our project, we already have the full BitVM implementation on our verification layer. I think in one or two months ago. And then, and also for our BitVM bridge, that we also have a BitVM alliance together that we are building like the foundation of it. So we estimate that will also come out in the next 1 to 2 months. So yeah, so the answer is definitely yes. It will be production ready very soon. And your second question is around BitVM versus OPCAT. I think a lot of people kind of like overestimate the power of OPCAT. From our understanding, you can definitely streamline, like in the process of, how Bitcoin verifies Snark proof. But with Snark, like other proof system, it doesn't do much help. And then essentially, you still need BitVM even if you have OPCAT. And there are actually, more important issues that you need to solve. Other like potential opcodes that are better candidates to be reactivated compared to OPCAT.
Yeah, so for BitVM, like it's been built for like more than a year, but it changed actually like 3 versions. One was in the paper, which is based on gates, and the second was the CPU architecture, and the third one is the BitVM2, or like variants of BitVM2. It's changing a bit from the paper, but it's still like the Snark verifier, and the Snark verifier is already being built. It's I think just like equal to 1 gigabyte of script right now, and there are teams working on chunking, and our team is working on Bitcoin Lite clients, as well as improving the winterness signatures. So it will be production ready very soon. It's not that far, or it is not unrealistic, but obviously OPCAT is something else. It needs to have a soft fork on Bitcoin, which is very hard to get through social consensus and also the technical challenges. But if we get ever OPCAT, I think we can still use BitVM style optimistic verification through OPCAT, but we don't need to do all the pre-signing stuff because we can build covenants using OPCAT. So it maybe still be optimistic, but the experience for developers to build these bridges will be much more simpler.
Yeah. So like first, I was like to tell like all the guys who are not very technical here that using the OPCAT we can do concatenations, and through that concatenations we can actually make whatever the process we are doing in the Bitcoin scripts more efficient. So like my point on the OPCAT is majorly like it will actually bring efficiency gains, but it's not what it's like projected to be. Because if you see right now, everyone is like going extraordinary like bullish claims on the OPCAT, which was somewhat exaggerated. Like on the Bitcoin implementation, like I believe it's like quite good. The thing is like using OPCAT, we can get some efficiency gains there, but end of the day, like the capacity of like Bitcoin for like processing is like relatively limited. So there we believe like there can be multiple different opcodes who can help that, because right now if you see the implementation, it's like good for like few big players, but I see like there are a lot of challenges if you believe like there can be, let's say, 100 or 200 different protocols using like Bitfim to all at once.
Yeah, so yeah, actually between the OPCATs and BWM2, basically it's like we implement the will file based on snack versus stack. Okay, so basically, when we from this point, snack is based on the group operations. It's more more complex compared to we verify the stack or we prove by stack. Yeah. So because the stack just need the hash function. Okay, the hash function just needs the concatenates between two inputs and find and calculates the one output. Okay, so basically if we have the OPCATs, everything become easier, and it became, and as he mentioned, we don't even need the pre-sign, or we have not of pre-sign in Bitcoin too, right? So we don't need the pre-sign. We can verify the proof. We can really verify the proof by Bitcoin. Okay, so from my my point is, I think we need to go forward with Bitcoin, with BitVM, and meanwhile I think if the OPCAT is approved to the mainstream, I think that's good for everyone, for the builder, for the end user, projects, so. That's my
Thank you. It's actually very interesting because some views presented are quite contradicted. And one of my questions is, on one side you have people that prefer snarks, on the other side you have people that prefer starks. On one side you have people that think BitVM is a very good approach. On the other one, some people would like to see OPCAT enabled again. How do we make a coherent Bitcoin L2 space with all these different actors? And what would an ideal layer 2 space for Bitcoin look like with all these different actors and all these different approaches?
Yeah, definitely. There are many different opinions around this topic. And then for us, we think that at Fiamma, we would go for the most trustless and also the most pragmatic way to do things. So even when they're OPCAT enabled, then we can incorporate that into our design. And then and also I think that we don't necessarily need a coherent L2 space in Bitcoin, because in the early stage it's good to have different teams that have different technologies. And from my perspective at Fiamma, we build things based on the fact that based on what exactly the problem is. So we see that now the problem is really in how to enable trustless Bitcoin transfer from Bitcoin L1 to other programmable blockchains, including Bitcoin L2s or other layer ones. And also how to enable more applications that can be built on Bitcoin, that can inherit the network security of Bitcoin. So that's why we build verification layer and also build the bridges and other protocols rather than directly build another Bitcoin L2s. So I think that we are also quite different in the case that we would look at the problem and try to solve it. And then like a lot of other teams like Saugier, they're building L2s. They're also have like a platform for other developers to directly deploy the apps on it. So I think it's good to have different things, so that you are not duplicating the work.
I think like it's all about possibilities. Today for us, for our ZK VM, Stark is the best approach because it's faster and unbounded and we don't have to write circuits from scratch. So our ZK VM proofs are actually Stark, but the verification is not possible through Stark on Bitcoin without having OPCAT. So we do the best we can do by just wrapping the Stark proof into another Stark proof to be able to verify. If we were able to directly verify Stark, we will probably do that. But like I said, it requires OPCAT to be added to Bitcoin through a soft fork, which probably takes time, and we don't want to get blocked by the Bitcoin social consensus. Instead, we want to just take the most practical approach to build what's possible today, and we can just improve our solution in the future if Bitcoin ever adds a necessary opcode for it.
And how we look at the future is like very close to Fiamma. And that's why like we are also building somewhere close to a settlement or a verification layer, basically trying to provide the Bitcoin security to like most of the ZK chains that we can provide in a very cost efficient manner. So like for verification on like the Bitcoin side, like we actually prefer like snarks, but the thing is like what we are aiming to do is like we have a lot of chains that have been built in the last few months. Like they've raised a lot good capital and they have created multiple different type of like ZK chains. What they're lacking is right now none of them is actually leveraging like Bitcoin security in any of the possible ways. So what we are aiming to create is like a plug and play solution, how they can easily integrate their current stack to us, whereas we can provide them with like ultimate settlement and whatever like security needs that they require. Basically infrastructure can be abstracted out for them so that they can focus on like building whatever vision for like whatever specialized apps or specialized games, whatever they're thinking of.
Okay, yeah. So for God network, I guess the question is about the decentralization and the programmability, right?
Sorry?
The question?
Yeah.
Yeah, is the balance between the scalability or the programmability, right?
No, it was more about the different approaches to scalability of Bitcoin, and how do we make a coherent space, or even should we make a coherent scalability space? Like for example, like Ethereum rollups basically all started by being like optimistic EVM rollups because it was like the first approach. Should we strive for a coherent space as well on Bitcoin, or should we push for more innovation and new things and not rely on existing solutions?
Okay, yeah. So actually, I don't have much comments about this. Basically, for God network, we build on the ZKM, and the ZKM is a big ZK virtual machine ecosystem that support different layer one. Yeah. So God network basically it's natively a stacked design. So we have a decentralized sequencer. We leverage the ZKM generated proof, and basically I think that's more like Alias. We leverage different components and build the EVM compatible 100 EVM compatible layer for the developers, and then we also use the ZK the technologies like BitVM to verify the proof for our God network, make sure that it inherits the security from layer one. Yeah. So basically that's how it works, and yeah.
Okay, thank you. Another question I have is about trust assumptions and decentralization of Bitcoin scaling solutions, because it's not an easy topic, and I know the Bitcoin community is quite attached to these values. when using a Bitcoin scaling solution today or in 6 months or in a few years, what are the different trust assumptions that you make? How decentralized is it, and how censorship resistant would it be?
Yeah, I will give a very quick answer to this. So definitely for the bridge that we're building, then so far we still need to trust that one of the operators are honest. And then we are actually upgrading it to enable forced exits, which in other words, it means that you don't need to trust any operators in the future. So, but that's actually not a very easy thing to do. But we would keep, pushing this forward to minimize the trust assumptions.
Yes, so for any of the solution today, if you are not getting double spend guarantee from Bitcoin and the data availability guarantee from Bitcoin, it's not possible to build anything trust minimized. So even though you have BitVM bridges, if what you are building is a side chain which is on DA layer and on validators, then you add another security and another trust assumption, which makes everything not trust minimized anymore. So the only way is just using Bitcoin as a DA layer and then building a BitVM bridge is the only way to get trust minimized. Other than we have trusted solutions like Lightning, maybe even Arc, but those solutions are also impractical on building applications. They are designed for payments, and they also have very strict scalability limits about the user experience, about the liveness, about the interactivity of them. So yeah, in the future, obviously everyone wants to be trustless, but it's not something easy to build. And especially for the solutions like we are building using ZK, it requires a soft fork.
Yeah, on the Bitcoin side, if we see, we do not have any kind of complete native smart contract functionality. And what we're trying to do is trying to emulate some sort of functionality using the Bitcoin scripts. And so that where we have come is one of interest assumptions. I believe this is good enough for any of the use cases which can be built majorly on the DeFi side, because theoretically speaking, you need one honest validator. But practically speaking, if you are one of the guys who are putting good amount of capital into any DeFi protocol, then you are incentivized to run your own validator. Until the process of running the validator is not very complicated and can be done in a easy way, then inherently the system will be honest, because there will be at least one person who's trying to secure his own capital, and in a way securing the complete protocol.
Okay, so God Network, it implements. I should say God Network takes the decentralization as its first priority from day one. So the first component we build is a decentralized network, decentralized sequencer. Then decentralized the proof network. Okay, the decentralized proof network is already there from ZKM. Okay, the next is decentralized the verify by Bitcoin. So, okay, so I think so for the security, when we say inheriting the security from the Bitcoin, okay, we usually include the security of the consensus of the layer 2, security of the lifeless of your layer 2, and the last but not least is the verification of your verify on Bitcoin. Okay, so so from this point, yeah, I think decentralized is okay. Decentralized is really important from our perspective. Yeah.
Thank you. And in a world where Bitcoin scaling reaches its full potential, what are the implications for other blockchains and the blockchain ecosystem as a whole? And how crucial is ZK to achieving this vision?
Yeah, I think that Bitcoin would definitely be the center of the future of the crypto world, and also we also envision that it would be the foundation for the future finance and also internet, because it's still the most decentralized and most valuable blockchain, after all these years. And then so in our product, so basically we have like BitVM bridges or similar, implementation that we can actually trustlessly bring this BTC to all ecosystem, all layer 1 like Solana, Tron, Ethereum, ETH layer 2, Bits layer 2, different ecosystem, so that for the first time, Bitcoin holders can trustlessly engage in the DeFi fun things that happen in other programmable worlds. And also we can potentially still enable real world, real use cases of Bitcoin, like you can pay, basically maybe you can trustlessly mint your stable coin based on your Bitcoin, and then you use those stable coin or interest earned to buy the coffee or like other stuff, in the real world. So, so I think it would definitely be the foundation and the center.
Yeah, I think most of the other chains will be that basically, because what Bitcoin created, like it was the first blockchain, and everything comes after it is just tries to emulate some functionality that's not exist on Bitcoin. But with ZK proofs now, actually we can do all the functionality on Bitcoin, just like we implemented EVM running on top of Bitcoin. So there's no need for other maybe EVM chains to also create an alternative, because you can do the exact same thing here, and you can just use the same asset Bitcoin for everything. So yeah, I think like it's already like there are a lot of chains out there that no one uses. So it will be much more like obsolete in the future as well.
So how we see like the Bitcoin is right now it is the chain which has the most amount of like capital on it, and that gives it a really big advantage compared to any other chain. Now the problem with the whole ecosystem is like you do not have any kind of smart contract functionalities, so you cannot do anything in a trustless way. And this lack of trustlessness is the thing that people are not interacting with a lot of like Bitcoin L2s or anything that's been built on Bitcoin. So once this security problem has been solved and user funds are actually secure, then it's a high incentive for the holders of Bitcoin to interact with these like protocols. And once we are able to achieve that, then that would unlock like a lot of Bitcoin liquidity for the Bitcoin L2s and everything built around it. And then that will actually bring in like good amount of developers. And with good amount of developers, we can create like a good amount of user experience. And once we have that, we can actually onboard like really new people doing something actually usable on the Bitcoin side. And here, how I see it, there's a little difference on the ecosystem is like the main Bitcoin will be more like a settlement layer, and all the executions will be happening either on a Bitcoin L2 or a side chain in a way, because Bitcoin has a very big block time, close to 10 minutes, which is not apt for any kind of like real world application. So how I see is there will be like app specific, a lot of like layer 2s which will be actually doing a lot of activities where people will be interacting with everything, and then everything will be settled on the main Bitcoin. This is how I see the future will.
Okay, yeah. So, okay, for the ZK, I think the first biggest application is the ZK layer, the Bitcoin layer 2, right? It's can empower the Bitcoin player, Bitcoin trader, Bitcoin builder to build all the different dApps like the ecosystem in Ethereum, okay, DeFi, SocialFi, okay, everything, yeah. So it's a very big difference for Bitcoin, I think. So ZK also, can, yeah, for developers, because we have for the Bitcoin we have the ZK, so we can trust the layer 2. We can, have the more. We can use the layer 2 to do different DeFi there. So they can. That means we have more transaction. Maybe we can create more values, both for the user itself and for the validators. Okay, so that means it's also benefits for the Bitcoin sidechain or anything projects or any other projects like that. So I think ZK can make it real big difference for the Bitcoin. Yeah.
Thank you. I would like to know if we have any questions from the public. I think we do not. We do have one.
Right. I would like each one of you to see a little bit further in the future with Bitcoin as the liquidity layer for all the other blockchains that supposedly only a fraction of what Bitcoin value is. Do you see a specific app each of you can kind of imagine for all of those?
I can maybe go ahead. Like, as a Bitcoin is the money, like it's created as a money, and like most of the other assets that is available on the market doesn't serve as a money. But as money, you have three properties like store of value, medium of exchange, and unit of account. I think Bitcoin has already succeeded on store of value, but the next two is the medium of exchange and then unit of account, which then you need actual places that you can use Bitcoin, and this excludes the custodial solution because it's just against the nature of Bitcoin. And as long as we are able to build layers and infrastructure to enable these two properties of the money, then I don't think any other asset than Bitcoin is required to be used as money. There will be obviously other assets in the world. There are many assets. There are stocks, there are commodities. But as a money, you don't probably need anything else.
Yeah, I agree. So definitely the store of value is the most prominent feature of Bitcoin. And so for a specific app that we envision is that it could be a stable coin or a payment app so that you can actually have your Bitcoin, locked trustlessly on the Bitcoin, and then you can also, mint stable coins and also earn interest based on your Bitcoin. So you can also use in everyday payment. I think this is a much better approach than a lot of our fiat. Yeah.
How I see this ecosystem growing is like as you guys said, it's correct. Like the Bitcoin is more like a money, and how I see is like there will be an emulation of whatever the financial activities that happen outside in the real world on the whole like Bitcoin space. And like how I see there is like there's like a really good opportunity if you guys like if anyone tries to use like core processors, because on the Bitcoin side we can do some sort of verification, but all the heavy computation or like we can create like actually very close to like order book or dexes and many other functionalities that are now coming upon Ethereum side, they can be directly emulated on the Bitcoin side, because on the Bitcoin we do not have any native smart contracts. So you can easily offload everything to core processors and you can just do the verification natively. So that can help you a lot.
Yeah. So when we talk about the liquidity, I think the first important is we need to be able to connect. I think we need to be able to connect the different chain. Like we have the different solutions for the permissionless bridge between the most of the layer 2 maybe EVM built on the EVM. Okay, so meanwhile we also need to consider Ethereum. We have a lot of topic about why Ethereum become what it is today. So I think from there we need to consider how to connect the different layer 2 and make sure that not to go back to the layer 1 to the other layer 2. Yeah, we need to consider connect the layer 2s natively. Okay, so from this point, I think we may need to have a consensus of maybe have a specific between or maybe a framework that's between the different layer 2s that they can recognize each other, like we can, okay, this is very good. Basically, we in ZKM there's concepts like the entangled graph. Okay, it's basically a framework that's a different layer 2 can interact with each other to make sure that the liquidity can be, can be flow between different layer 2s. Okay, so yeah.
Okay, Thank you, everyone. This will be the end of this panel. Thank you for participating and answering the questions and the discussion.
Thank you.
Thank you.
Thank you.
Thank you.
All right. Thank you, everybody.